Hi everybody, in this video we are going to be doing operations with polynomials. So we're going to be adding them, subtracting them, multiplying and dividing them. So just make sure you've got your notes handy and here we go. So the first part that we like to do is just to remind you, because we're going to have to be doing some things today about combining like terms. And so we just need to remind ourselves, what does it mean to have like terms? And again, here's your reminder that in order for something to have like terms, they have to have the same exact variable raised to the same exact power, or they have to have the same exact exponents in there. So if we look across in that first line, which of these are like terms? What I do is look at this first one, 7x cubed, and I look across the line and are there any other x cubed terms? Yeah, we've got an x cubed term here and an x cubed term here. So those would be considered like terms. Then our next one, I'm looking for an x squared term, and I see another x squared term over here. And then I'm looking, are there any y terms, just y terms by themselves, y to the first? No, there's no more. What about y squared? And yes, there's a y squared term here and also one over here. And then we want to look at the next line down. So we're just doing the same thing. Which of these are like terms again? So do we have anything that's just an AB term? So a simple AB. Yeah, it's way at the end. And I don't see any else at this moment. And then this term can be rewritten as 3a squared b. And so I would look across and see, do we have any other a squared b terms? And I don't see any. I see I see an ab squared, and I see an a squared b squared, but nothing else. So this one's a loner by itself. How about a b term? Do we have any other b terms? Yes, I see a b term here and a b term right there. B cubed, I don't see any other b cubed terms, so these are kind of lone men out. And then I see one here that's an a squared b squared, and there's another a squared b squared right here, because it's being -2a squared b squared. And so these two would be like terms right here. And then this 4ab squared is going to be another lone term out. So just reminding you about what that looks like. All right, so for our first example, we are just going to be simplifying and combining these polynomials. And so we're just going to start with adding. We're going to add these polynomials. So we've got this first one that's going to be y cubed plus 3y plus 2 plus another quantity of 2y minus 3y squared plus 4y cubed minus 1. So we're going to start with that. So what I would urge you to do is kind of look inside the parentheses first and see if there's anything we can do to combine any like terms. And in the first set of parentheses, there's nothing. There are no like terms. In the second set of parentheses, same thing, no like terms. So then I look at this and say, okay, well, we have an addition sign here in between our two parentheses sets. So those parentheses serve no purpose now. So what we can do, we've got y cubed plus 3y plus 2 plus 2y, I'm going to get rid of my arrow now, plus 2y minus 3y squared plus 4y cubed minus 1. And now I'm ready to combine like terms and then write my answer in alpha descending order. So what I like to do, so I don't have to write this polynomial out yet again and putting them all in order, I like to look through all of my terms and find out which is the term that should go first in my answer if I'm putting it in descending order, excuse me, because all of them alphabetically are all the same. They're all y's, right? So descending order means this term here, this y cubed, is going to be the one with the highest power. So let's combine those. So we've got a 4 and then a 1, right? That's essentially like a 1y cubed. So this is going to be 5y cubed. And then I want to look for my next term that I'm going to write down. And it should be this -3y squared. And I crossed it off, so I'm just kind of keeping account that I'm done with those terms. The next ones I'm seeing are this 3y and a 2y. So we're going to add that and have 3y and 2y is 5y. And then finally, we've got the plus 2 and the minus 1, which is going to be plus 1 at the end. And so there's our answer. So that's as simplified as we can get it, because we can't combine anything else. So let's look at another example. So our next one, we've got a quantity of negative 8m plus 5 minus 6m squared. And we're going to subtract a negative 5m squared minus 8 plus a 7m. So here again, look within your first set of parentheses. Is there anything to combine? No. Is there anything for us to combine in the second set? No. There's m's, but they're not raised to the same power. So now I look at the fact that I have a negative here in between. So what I want to do now is distribute that inside. It's essentially like there's a negative 1 right here. So we're going to distribute that in. So then we've got negative 8m plus 5 minus 6m squared. And then we've got this minus a negative is going to give us a positive 5m squared. Again, I'm going to get rid of my little arrow there so it doesn't cause any confusion. And then we've got a plus 8 because a negative times a negative is going to give us a positive. And then a negative times a positive is going to give us a negative 7m. And now we're ready to combine like terms and put it in alpha descending order. So the first term I see is going to be this one right here with m squared. So negative 6 plus 5 is going to give us negative m squared. Then we're going to have 8m and negative 7m. So a negative 8 and negative 7 is going to give us a negative 15m. And then we've got our last terms of a 5 and an 8. So it's going to be plus 13. And then that's our final answer for that. Let's try one more addition subtraction one. All right, so our next one is going to be 4x minus 8 minus 3 times the quantity of negative 1 plus x minus the quantity of 11x plus 5. So on here, look within your parentheses first, see if it's anything you can simplify. First set of parentheses, no. Second set of parentheses, no. So what would be our next step? What should we do? What do you think? What I'm hoping you're saying is multiply. So I know it's tempting to take this and maybe subtract that. Don't do that. You should, why isn't that erasing? You should in here go ahead and multiply. So you want to multiply here, and then you want to multiply here. So then we're going to have 4x minus 8 plus a 3 minus a 3x minus an 11x minus a 5. So now at this point we need to simplify combine like terms. So we've got 4x minus 3x minus an 11x. And my brain likes to do the 3x and the 11x first because I know I'm going to get negative 14x plus a 4x, which should give us a negative 10x. And then finally over here, we should be getting negative 8 plus a 3 minus a 5. And again, I like to do the negative 8 and the negative 5 in my head, thinking I've got negative 13 plus a 3, which is going to give me negative 10 for my final answer. All right. I am going to try to squeeze in 2 multiplication problems. Watch out. Maybe I can squeeze them in over here. All right. So number 4, we've got a multiplication problem. We have got negative 4a cubed times 3a to the 5th, and you were asked to multiply. So this is kind of what we were doing the other day with exponents and doing our rules. So thinking about how this is multiplication, so we're going to take negative 4 times 3, which is going to give us negative 12. And then a cubed times a to the 5th. Remember, same base, so we can add our exponents. So that means we're going to have a to the 8th for that one. And then that's your final answer for here. And then for number 5, we have got, our next one is going to be negative 4a cubed b squared, and we are going to multiply that. I'm going to have to write really small. watch out. So it's going to be 3a to the 5th b minus 2. I did it. Can't believe I squeezed that in there. All right, so because of this two terms in here, we've got a binomial on the inside of the parentheses. We want to take these terms and we're going to distribute here. So then that means our first term is going to be negative 12 a to the 8th b to the 3rd. So I want you to think about that. So what we did is I just took the two numbers, negative 4 times 3, that gave me negative 12. Then I'm taking like a to the 3rd times a to the 5th. And so same base, so you're going to add the exponents. And then we're doing b squared times b. So same base, add the exponents. So it's going to be b to the 3rd. And now we're going to multiply the next by the next term. And a negative times a negative is going to be a positive. And so it's going to be positive 8a cubed b squared. And that's your answer for that one. All right, so we're going to go to the next page and we're going to do several more examples. So we're going to do some more multiplying, dividing for the page after that. This is like the day full of examples. All right, so number 6, we are going to have 3x minus 4. And then we are going to multiply that by 2x squared plus x. One thing I like to show you guys too is that we can do something called the table method if you would rather not FOIL. And the table method, you just put your terms in a table. And so the first one, we can do 3x, and then we can do, that's supposed to be an x, minus 4. And then up here, we can do 2x squared, and we can do an x. You can change those around. So 2x and x could go vertically, and the 3x minus 4 could go horizontally. That part doesn't matter. So then when we're multiplying, we would take 3x times 2x squared, and that's going to give us 6x to the 3rd. And then I'm going to take 3x times x, which is going to be 3x squared. And then I'm going to take negative 4 times 2x squared, which is going to give me negative 8x squared. And then I'm going to get negative 4x because it's negative 4 times x. And then typically, not always, but typically along the diagonal, you can combine those like terms. And so then our answer would be 6x cubed minus 5x squared minus 4x. And then that would be the answer to your problem. Otherwise, you can do FOIL. And FOIL again means F is for first terms, and then outside terms, and then inside terms, and then last terms. So it's going to be first, which is F, and then outside, which is the O, and then the inside, which is this one, and then the last, which is the L. So anyway, if we did the first terms, we would have 3x, and this is me writing more work than I normally have you guys do, but it'd be 3x times 2x squared plus 3x times x minus 4 times 2x squared minus 4 times x. And then you're simplifying, combining like terms. So up here we would have 6x cubed plus 3x squared minus 8x squared minus 4x. And then we're combining those. So then we would get 6x cubed minus 5x squared minus 4x. And so we get the same thing. So anyway, you can do it either way. I don't care, whichever way you would prefer to do. So then we're going to look at our next example. So number 7, if we have 2x squared y, and then we're going to multiply it by xy plus y squared times x minus 3y, and we've got that problem. So one idea, it doesn't really matter. You can start with the two binomials and multiply them, or you can start with the monomial out front and multiply it by binomial. And that's what I'm going to do. I'm just going to work from the left to the right. So here I'm going to take this and we're going to multiply it by this. So then we're going to get 2x to the 3rd y squared plus 2x squared y to the third. That's now going to go as a binomial, and I've got to multiply it by x minus 3y. I'm going to move this up and give myself a little bit more space. I would also be looking inside my parentheses to see if there's anything I combine, because these look really similar, but they're not the same. So unfortunately, I can't combine them to make this easier. So now we can FOIL, or you can do the table method. So I'm going to do my first terms. So that's, for me, is going to be 2x to the fourth y squared. Now I'm going to do the outside terms. So positive times the negative is going to give me negative 6x cubed y cubed. Then I'm going to do the inside terms. So I'm going to get plus 2x to the third y to the third. And then the last terms, minus 6x squared y to the fourth. And then the only ones we can combine are in here. And so then we've got 2x to the fourth y squared minus 4x to the third y to the third minus 6x squared y to the fourth. And that's going to be the end of that problem. Let me see. Just picking out which one we're going to do next. All right. Another one that I would like to try. What I would like for you to do, I'm going to cross off one of our examples. I'm just not going to do one. And cross that one off. Okay. So one of the examples we are going to do next is the one that looks like this, and it's going to be 2x plus 3 quantity squared times 2x minus 1. And I'm going to set this one up for you, and then I'm going to have you guys finish it. So this one, I know you might be tempted to take that and distribute it in. Remember, that's when math sirens should be going off in your head. You cannot distribute that negative or that exponent across an addition or subtraction sign, only if it's multiplication or division on the inside of those parentheses. So what that means is that we are going to write this out as two binomials. So it's going to be 2x plus 3 times 2x plus 3 times 2x minus 1. So here, what I would urge you to do is just forget about that 2x minus 1 for a second. So forget about that 2x minus 1. Go ahead and FOIL this. And then once you simplify combined like terms, you're going to get a trinomial. So it's going to be something plus something else. And it's all going to be pluses because we've got pluses on both spots there. Then you're going to take that trinomial and then you're going to distribute it into that binomial. And so this next part, you have to be careful you don't miss any of the terms. You're going to have 6 terms at the end of it because you're going to need to go the first term times the first term, and then this one, the middle term, and then that last term. So you're going to have 6 terms. You should be able to simplify, combine some of them at the end, and your final answer when you are done should come out to 8x cubed plus 20x squared plus 6x minus 9. So that should be your answer when you're all done. So just make sure you finish that problem and then you check it and see how you do. And I'm going to give you 2 more to try on your own. So then the other one I want you to try is going to be 6m plus 5n, and you're going to multiply that by 6m minus 5n. And then the last one I want you to try is going to be 3x minus 2 times 3x minus 2 times 3x plus 2. So I want you to try that one out and see how you do on those. Number 9, when you're finished with it, you should be getting 36m squared minus, oops, just like let my pen slip all over the place. 36m squared minus 25n squared. And then number 10, when you're done with it, should be 27 x cubed minus 18x squared minus 12x plus 8. So I'd like for you to try those, and then I'm going to make note of that. And then we're going to work on our dividing. So dividing our polynomials. I don't even know what example this is anymore. Number 11. Number 11. Okay, so if we've got 16x to the 5th y squared, and that's going to go all over 28x squared y to the 9th. So we've got that as our problem to start with. What I want you to do is look at just the numbers first and find out, is there anything that we can take out of both the numerator and the denominator out of 16 and 28? And I'm hoping that you say, well, at least a 2, and then maybe some of you are saying a 4. And it's true, you can take out a 4, you can also just start by taking out a 2, and then you need to take out another 2. So then that means in our problem, we've got 4 over 7 so far. And then of your x's, how many, like, where's the largest x? Like, where's the highest power? It's in the numerator. So how many x's are we going to be taking from where? We're going to take 2 from the denominator. So now we've got x to the 3rd, and we're going to pull these 2 from the numerator down to the denominator. And so then we've got y to the 7th. And so then that gives you your answer for that one. We could also rewrite this, just be aware, we could also rewrite this as 4/7 x cubed y to the -7th. Those are both the same. So if you wrote it like this, or if you wrote it like that, those would both be correct. So I'm going to give you another one over here. So the next one, let's say we've got 5m to the 3rd minus 9m squared plus 10m, and we're going to put that all over 5m squared. So what I would like you to do, this isn't going to be too challenging. What we're going to do is that we're going to split it up. I want you to take that first term in the numerator, and we're going to say 5m cubed all over 5m squared. The next thing I want you to do is look at the signs of your terms. We've got a negative over a positive. So a negative over a positive, what's going to be the sign of my next term? If we have a positive and a negative, it's going to be a negative. So then my middle term is going to be 9m squared over 5m squared. And then the last one, we've got a positive over a positive here. And so it's going to be plus, and then it's going to be 10m over 5m squared. So then we're going to take each of these terms on their own, and we're going to simplify them, just like we did in this example here in our number 11. So here, 5 and 5 is going to reduce. I'm going to take these 2 off and subtract them off up here. So then I've just got m to the 1st, and m to the 1st is just going to give me m. So then the next one, I am looking at how the 9 and the 5, there's nothing that's going to change about that. We have the 9 and the 5, but the m squared and the m squareds are both going to cancel out, right? M squared over m squared is just 1. Or if you thought of it like this, you could also think of it as like, well, let me take these 2 off of the top 2, and you would get m to the 0, and m to the 0 is just 1, right? And 9 times 1 would give us 9 in the numerator. Okay, so finishing off that last fraction, this would be a 1, this would be a 2. I'm going to take this 1m off down here. So then I've got 2 over m to the 1st, and the denominator just 2 over m. And this looks kind of messy, but this is your answer. So this is totally fine to leave it like that. So that's going to be your answer for that one. So then we're going to do a couple more. So number 13, we've got 8 xy squared minus 9x squared y plus 6x squared y squared. And that is going to go all over negative x squared y squared. So this one, I would like you to try on your own. So try this one out. You're going to split out the terms again, just like what we did in the previous example. So I'm going to have you try this one. And then when you are done, the answer should be, just so you can check, negative 8 over x plus 9 over y minus 6. You can also rewrite that as negative 8x to the negative 1 plus 9y to the negative 1 minus 6. Both of those are correct, and you should be able to recognize both of those as being the same. So you need to have both those answers written down. So I want you to try that one on your own, and then I'm going to do this next one with you. And this one we've got negative 3 squared a squared b to the 4th plus 3 to the 6th a to the 3rd b to the 3rd plus 3 to the 0 a to the 3rd b to the 4th. And then we're going to put that all over negative 3a to the 5th, a to the 3rd, oh, sorry, negative 3, so this should have been negative 3 to the 5th. And this can be a to the 3rd. And then this one will be, let me get rid of this, b to the 4th. Okay, now we're ready to kind of split it up. So here, the negative over the negative right here is going to give me a positive. So I'm going to have positive 3 squared a squared b to the 4th all over 3 to the 5th a to the 3rd b to the 4th for that one. Then I've got a positive over a negative, which means the sign's going to be negative. And then I've got 3 to the 6th a to the 3rd b to the 3rd all over 3 to the 5th a to the 3rd b to the 4th. Finally, we've got a positive over a negative. So I've got a negative that's going to come here. If you would like to, you can think about this 3 to the 0, it's 1, right? So 3 to the 0 power is going to give us 1. So I'm not even going to write the 3 there. And so now I've got a cubed b to the 4th all over 3 to the 5th a to the 3rd b to the 4th. All right, here we go. So now I'm going to take these. Again, we have the same base here. So we can just take those two away, subtract them down here. I'm going to take these two away and I'm going to subtract them down here. And I'm going to take the b to the 4th over b to the 4th is just 1. Or you can think about, okay, I'm going to take those 4 away down here and it's going to be b to the 0 and b to the 0 is 1. So what's left in my numerator? Don't say nothing because it's not true. What's left is this reduced to 1, this reduced to 1, this reduced to 1. 1 times 1 times 1 is 1. So we've got 1 there. Then we've got 3 to the 3rd, a to the 1st, which you don't need to write 1, just going to be a. And then we don't have any b's, so I can shorten that parenthesis or shorten up that fraction bar. And then I'm going to go ahead and I'm just going to say, well, what is 3 to the 3rd? So 3 times 3 is 9, 9 times 3 is 27. So we're going to have 27a in the denominator. So 1 over 27a. All right, next set of parentheses. So here I'm going to take the 5 off from the denominator, bring it up top. So 3 to the 1st is just 3. A to the 3rd over a to the 3rd is just going to reduce to 1 and 1. And then I'm going to take these 3 off in the numerator, bring them to the denominator, and I've got b in the denominator. And so that's all I've got left in the denominator. So then in the next one, again, I'm going to shorten up my fraction bar. I've got negative, and then I'm just going to go ahead and put 3 to the 5th in the denominator for now. A to the 3rd and a to the 3rd are going to cancel out. B to the 4th and b to the 4th are going to cancel out because it's the same number over the same number. What's left in the numerator? Not 0, it's 1. So I'm going to have 1 over 3 to the 5th. So here we go. I'm going to write up my answer so it's a little bit neater. It's going to be minus 3 over b minus, and then you need to evaluate what is 3 to the 5th. Put it in your calculator, and you should be getting 243. You could also rewrite this as 1/27th a to the negative 1 minus 3 b to the negative 1 minus 1 over 243 for this one. So those are both the same. Okay, if you've got questions, let me know. Thanks. Bye.